In order to be efficient at addition and double angle formulas, you'll need to have be very comfortable with your unit circle, as well as with setting up right triangles and finding sine and cosine. Let's begin with a quick exploration of the need for addition formula. So if we assume that A and B are two different angles, is it true that sine of A plus B is the same as sine A plus sine B? If we say sine 90, so let's assume that both A and B are 90. Is that the same as saying sine 90 plus sine 90? Well, in this case, order of operations, right? You get 180. And a sine of 180 is 0. However, sine of 90 is 1, and sine of 90 is 1. 1 plus 1 is 2. Notice that we get 0 is equal to 2, which is not true. So in other words, what we're saying is that sine of A plus B is not the same, in this case, sine A plus sine B. So there is a great need for something to show the difference. So if we say, let's say A is 60 and B is 30. Well, the sine of 60 would be, try a different color. The sine of 60 would be radical 3 over 2 using the unit circle. Okay, we're not going to be using decimals in this section at all. We'll be using exact values. If we do B is 30, sine of B is 1/2. Now, if we do sine of A plus sine of B, it is this setup right here. And we end up with a very weird fraction, 1 plus radical 3 over 2. However, if we were to take A plus B, right, that's 60 plus the 30, we would get 90, and sine of 90 is equal to 1. So once again, notice that these numbers, 1 and 1 plus radical 3 over 2, are not the same answer. I give two more examples of radians. We're not going to focus on radians much, but just to show you that if we do the same thing again, use the unit circle, in this case, you get radical 2, and then you get a 1, which are not the same. And in the third case, if we do the same thing, you're going to get 1 plus radical 3 over 2, and this is 1. The point of this is the following, that whatever answer you get in this column is not the same as if we were to just add them up inside and then find the angle. All right, the point being that they're not the same. Note that sine A plus B is not equal. Right? I'm saying it again, just in case you're not aware. They're not the same thing. However, what we do notice based on the above, we notice that sine of A plus sine of B is greater than sine of A plus B. Right? We were getting like radical 2, we're getting 1 plus radical 3 over 2. On the right side, it was always going to be 1 so far for this problem. However, there are a few cases where this is true. On that note, can you think of a case where sine of A plus sine B is equal to sine of parenthesis A plus B, parenthesis? For what values of A and B would that be true? In our further insistence that they're not equal, I want to show you with the geometry. In this example, AC is 1. So this is from here to here is going to be 1. If we set up sine of alpha, right, of this angle right here, for this triangle right here, however, BC over 1 is just BC. Sine of beta, here's beta. But once again, A over C is 1. And instead of putting all that, we could just put that it's CD. With that being said, sine of alpha plus sine of beta would be BC plus CD, right? Because sine of alpha is BC and sine of beta is CD. In other words, what we're trying to show here is that if you wanted to get the sine of alpha and the sine of beta and add them up, that would be like you traveling from B to C and then from C to D. So imagine if this is a map imagine that you have to leave town B and then hit town C and then leave town C and get to town D to get from B to D. That's what sine alpha plus sine beta looks like. However, if we were to do sine of alpha plus beta, that means from here to here, this whole thing, we would just simply go from B to D. Notice that B to D is a shorter distance than going from B to C and then C to D. So once again, the whole purpose so far has only been to show you that sine of alpha plus sine of beta is not the same as sine of alpha plus beta. For your summary, give an example as to why sine of A plus sine of B is not equal to sine parenthesis A plus B. We now present the addition and subtraction formulas. Sine A plus B should be sine A times cosine B plus cosine A times sine B. All right, in other words, you have two angles, A and B, and they pretty much get swapped, right? Cosine A plus B, well, here you go. Well, similar fashion, but be aware of this minus. I have double checked these formulas to make sure that for their accuracy, they are correct. If we're doing addition for cosine, it is minus, and this time the cosines are lined up together and the sines are lined up. And then we have the subtraction. Sine A minus B is pretty much exactly the same, except it's a minus. And then, of course, the cosine A minus B is exactly the same, except it's a plus. So with the minus for the cosine, you have a plus. What happens if one of those angles is 0 degrees? Well, let's find out. Let's take, for example, let's let B equal 0. And let's use the sine addition formula. So everywhere where I have B, I'm going to put a 0. Now, again, you have to be good with a unit circle. So I was trying to suggest print out your unit circle or bust it out or whatever, but have it ready for every problem that we do with this stuff. So A plus 0 is going to be just A. Cosine of 0, this in the unit circle is 1. Sine of 0 is 0. And what happens then is cosine times 0, that's gone. Will we be doing proofs? Yes. This last topic will require you to pretty much be good at almost everything except for graphing. If one of the angles happens to be 0, well, we end up with just a true statement. Sine is sine. So in order to work on these problems with the addition or subtraction, you have to first draw two different triangles. You have to keep track of the information that's been given. Keep in mind what quadrant they're in and where the answer might be, in what quadrant. You will set up two different triangles based on what they gave you. You will use the Pythagorean theorem in many cases. And don't forget to add the sines at the end. We will have some examples of that later. You're going to set the sine and cosine for each angle, substitute into the appropriate formulas. And the appropriate formulas would be these up here, these four that we gave you. Substitute, and then if you need to do common denominators, you're going to do that. For this summary, it's a bit long-winded, but I need you to kind of brush up on some skills. Given the sine of A is 1 over radical 10, I want you to set up the right triangle, that has an angle A, based on what was given, label the correct given sides, find the missing side, hint it should be 3, use the Pythagorean theorem, and then explain in words what you did to solve it.